Hi folks, we're going to take a look at page 74, number 11. So they're looking for the equation of the tangent to this curve, which is also parallel to that line. Okay, so first thing I notice here is I don't know what point at which the tangent touches this curve here, so hopefully that'll come out in the work that I have to do. So I know that the tangent has to be parallel to this equation here, so I guess first thing I should do is determine the slope, since I know two parallel lines will have the same slope. So if I solve this here, I have x plus 4 is equal to 6y, so y is equal to 1/6 x plus 4 over 6. Don't care about reducing that, because all I care about is that the slope that I'm going to be working with is 1 over 6. Okay? But I also know that the slope of this tangent is given by the derivative of this function y. Okay, now we don't have any derivative rules to find this derivative more easily, so we're going to have to put it into the limit definition to determine the derivative. Okay, so the derivative of y is given as the limit as h approaches 0 of the function evaluated at x plus h, so square root of x plus h plus 1. Okay, minus the function itself. So here, root of x plus 1 all over h. Okay, and as usual, anytime we've got one of these binomials with square roots, it makes sense to rationalize the numerator in order to be able to do some algebra and hopefully reduce the h in the denominator. Okay, so I'm going to multiply both top and bottom by the conjugate here. So root of x plus h plus 1 plus root of x plus 1. And same thing in the denominator. X plus h plus 1 plus root of x plus 1. Okay. So in the numerator, we have our difference of squares. So the first squared minus the second squared. So this is x plus h plus 1 minus x plus 1, since I'm just squaring these two square roots. Again, please remember to put brackets around that second term, or else you will make a sign error, and that will ruin everything. Okay, in the denominator we have h times that big expression. Okay, and hopefully some nice reducing happens, and here that x minus x goes, and the 1 minus 1 goes. So the only thing I'm left with in the numerator is h, which reduces with the h in the denominator. Okay, so just to be sure you know what I'm doing, the only thing left in the numerator is that h term, which reduces with the h in the denominator. Okay, so now let's write out what we have left. And since I've managed to eliminate the issue in the denominator, I can now just evaluate the limit by inputting h equals 0 into the expression. And what we have here is, as h approaches 0, this denominator approaches, the first term approaches just root of x plus 1. There's no h here. It does not change as h approaches 0, so it just remains the same. Okay, and now I've got 1 over 2 times root x plus 1. Okay, so now I know what the slope of the tangent must look like at whatever point we're going to be finding the tangent to. Okay, and I know that that slope must be equal to 1 over 6. So now I can just equate these two expressions. Okay, so let's see where that takes us. So I've got 1 over 2 times root x plus 1 has to be equal to 1 over 6, and now I can solve for the x value, which gives me this result. Okay, so cross multiply, so 6 is equal to 2 times root of x plus 1. Divide both sides by 2. So now I'm going to square both sides in order to get rid of that square root. So I'm left with 9 is equal to x plus 1, and so x is equal to 8. Okay, so this is the x value, which is going to have a tangent with a slope of 1 over 6. Okay, but in order to find the equation of the line, because we're actually looking for the equation, not just the location of this tangent, I'm going to need the y value. So use the equation to find the y value. So square root of 8 plus 1, which is a square root of 9. So that's just equal to 3. Okay, so now I've got my point 8.3. I've got my slope 1 over 6. Okay, a couple of ways you can do this, but I'll just throw this into y equals mx plus b and solve for the b value. Okay, so 3 is equal to 8 times 1 over 6 plus b. So reduce, this is 4 over 3. So when I bring this over to the other side, I might as well put this as a fraction over 3. So 3 becomes 9 over 3 minus 4 over 3. And so b is equal to 5 over 3. Okay, and my final answer is y equals slope of 1 over 6 times x plus 5 over 3. Okay, now I'm perfectly fine for you to leave the answer in this form. The textbook seems to give all their answers in standard form, so I'll just do it once just to make sure everybody's on the same page as how to do that. So here what we want to do is eliminate all the denominators and bring all the terms to one side of the equation. So eliminate the denominators by multiplying by the lowest common denominator, which in this case was 6. So I'll multiply both sides of the equation by 6. So I get 6y equals x plus, here, multiply this. Let me just show it out here. If I multiply that one by 6 over 3 is 2, so plus 10. And now bring everything to one side of the equation. I'll bring everything here. So I've got x minus 6y plus 10 is equal to 0. Okay, so either that or this are both acceptable answers. Okay, so just to give a quick recap, number 1, we want the equation of a tangent, so that's why I have to give the equation of a line. I use the fact that it's parallel to this line to determine the slope, and I use the derivative to find an expression for the slope which contains the x value which I'm looking to find. Okay.